try to get through as many of the questions for the practice exam in video form as I can. I can't guarantee that I'm going to get through all of them. It's a pretty long package, but I'm going to start and I'm going to see how long it's taking me. I'm going to try to find that balance between explaining and moving efficiently through this, because I think it would be ideal if there could be a video explanation for each of these questions. All right. So we're going to start with question 1 here. And actually for question 1, because I want to have these functions listed on the left, I think I'm going to try and zoom this camera out a little bit. I'm going to try and write a little bit bigger as well, so that things are all in the field of view here. Okay. So I guess we need 3 things. We need these functions, we need the questions themselves, and we need the solutions. All right, so I'm going to work it out sort of like this. All right. So question 1a, can we see that in the video? We can. Okay, cool. Looks like we're looking for f of 2 plus g of 0. Okay, and my f function looks like it's x squared minus 4x plus 3. So I could rewrite f of 2 as, maybe I'll use a different colored pen. So instead of 2, I'll write 2 squared minus 4 times 2 plus 3. And then I'll be adding to that the g function. And g function is right here, and it just says g of 0 is 8. It leads to the value 8. And so we'll be adding 8 to that. All right. So using BEDMAS, we should probably do the exponents first. So I've got an exponent here, so I'm going to rewrite 2 squared as 4. I'm going to take away negative 4 times 2. This is going to give us negative 8 plus 3 plus 8. And then we're going to add and subtract these. Now I can see a negative 8 and a positive 8 end up canceling out. So really we just have a 4 plus 3, which is 7. Okay. Let's move on to question B. All right, question B, we've got h of negative 2 plus h of 2 plus h of negative 5. All right, and we've got this h function down here. Okay, so h of negative 2 means an input. Inputs are on the x, and outputs are on the y. So that means we have x here, and on the output we call that h of x. So my h of negative 2, and my input is negative 2, looks like my output is this value here, 2. Okay, so h of negative 2 is 2. We're going to add to that h of 2, so my input of 2, I'm going to trace that down, and I find I've got negative 1 here. I'm going to put that in brackets. And lastly, h of negative 5. So I'm going to add to that. My negative 5 input comes down. It looks like it's negative 1/2. So it'll be negative half, like that. All right, then we're going to just group all those numbers together. 2 plus negative 1 is like 2 minus 1 is 1. And then plus another negative half should give us 1/2. All right, moving on. Question C. All right, let's see here. Okay, f of 0 plus h of negative 6. All right, so my f function is here. So if I put in 0 for x, I'm going to have, so that's going to be a big complicated expression. We'll make that 0 squared minus 4 times 0 plus 3. And I don't know why I put that 3 in brackets. I'm going to just do that. And then add to that h of negative 6. So my h function, negative 6. It looks like when x is negative 6, y doesn't seem to have an output at all. Oh, okay. So I might just represent that with a little null symbol. And so this means, actually, that this whole addition of functions does not exist. And I want to point you to the top of this page here. If an expression does not exist, we're going to write dne. So for this whole function, or I guess the composite function, is not going to be, I guess, -1 plus dne. dne is not a value. The whole answer. This is the answer to the whole question, which is that, just dne. Okay. So step 2 is we need d, for d rather. I don't know why I said step 2. Maybe I can paste this over like that a little bit. Alright, that's not bad. Alright, so for d, we've got f of g of -2. Okay, so I need my g function of -2. It looks like -2, g of -2 leads to 7. Okay, so that's like saying I really want f of 7. And that's equal to, because g of -2 is 7, so that gives us a value of f function, it's right here. It says x squared minus 4x plus 3, so it'll be 7 squared minus 4 times 7 plus 3, or 49 minus 28 plus 3, which is 52 minus 28, and 52 minus 28. I feel like at this time of the day I'm going to make a mistake doing that simple subtraction, so I'm just going to grab a calculator. 24. Okay. And that's our output there. All right, let's move on. So we've got question E here, g of f of 4. Okay, so for question 1E, we'll have g of f of 4. And f of 4 is going to be a complicated function. I could do that, write that off to the side. However, I think what I'm going to do instead is just going to replace f of 4 with a big input, and that's going to be 4 squared minus 4 times 4 plus 3. And I'm going to evaluate everything inside this function, so that's going to be 16 minus 16 plus 3, which is to say we'll have g of 3, like so. And then I can look at my g function and say, well, it doesn't look like 3 is an acceptable input. So this does not exist as well. Okay. Move on to f. So here we've got f of g of h of -4. Okay, so we've got f of g h of -4, and we're going to work from the inside out. That's usually how we approach these. So we're going to start with g of h of -4. Pardon me, h of -4. So we've got f of g, and we'll replace this bracket with whatever h of -4 is. If I look on this graph, I can see h of -4. -4 for my input doesn't move me up or down on my y-axis. In fact, gives me the value right here, 0. And so that means the output there is 0. And then I say, okay, well, what's g of 0? 0 is my input, 8 is my output in g. So that means I get f of 8. And then f of 8, I'm going to put 8 in for x for each of these values. So that's going to be 8 squared minus 4 times 8 plus 3. So f of g of h of -4 is going to be 64 minus 32 plus 3, which is 32 plus 3, which is 35. Okay. So we'll move on to question G. So G, we've got f cubed of 1. So what that really means is, it means we have f of f of f of 1. So that means we're going to put 1 into our f function, crunch the numbers. We're we're going to take that output and put it back into the f function, crunch those numbers, and then take it and put it back into this final outside f function. All right. So I'll rewrite this as f of, I'm going to leave some space here, and I'm going to put 1 in for my f function here. Okay, so my f function is x squared minus 4x plus 3. So it means I'm going to have 1 squared minus 4x plus, 4 times 1. So times 1 plus 3. Let's write a little dot there so we don't get confused. 4 dot 1. All right, and so that's to say that we have f of 1 minus 4 plus 3, or 1 plus 3 is 4, and it gives us 0 actually. Okay, so now we're going to find out what f of 0 is. Okay, so f of 0, I'll use a different color here, gives 0 squared minus 4 times 0 plus 3, which is to say we get f of 0 minus 4 times 0, which is also 0, plus 3. So it's actually going to give us f of 3. Okay. And then lastly, we're going to take that value and plug it in to our function here. So we got 3 squared minus 4 times 3 plus 3. This is 9 minus 12 plus 3, 12 minus 12, so that gives us 0 in total. Okay. So that was, what was that? FG. Okay. And so for G, so we got H now. Okay, so H, 1H, asks us to find the inverse of G of 8. So what that means is that this is actually, we want to think of this being the output of G of X. I don't know why I did that. There we go. And what is going to be out here instead, because it's an inverse, means we're going to be looking for the input for G of X. That gives 8. Can't see it off the screen. 8 as an output. Okay. So let's just check here. So we kind of read this G function backwards. We're told the output is 8. What input gives us the output of 8? It's 0. So there's our answer there, 0. Now let's move on to I. I is also an inverse, and so we're going to be given the same situation. We're given an output, and we're going to be looking for all of the possible inputs. So an output of 2, if I look here on this graph, actually it looks like there's only one input, one x value that gives us an output of 2, and it's the value negative 2. And that's the only one. Okay. Last one, J. We've got the inverse of whatever f of negative 1 is. F of negative 1. So I'm going to plug in negative 1 into my f function, which is this function up here. And so I'm going to get negative 1 squared minus 4 times negative 1 plus 3. Now, so it's going to give us G of negative 1, and it's going to be negative 1 squared, which is 1. Negative 4 times negative 1 is plus 1 plus 3. So we're really looking for G negative 1 of 5. And just so we're clear here, again, what we're really looking for, did I write the right letter? Is that H? Just want to double check there. That seems a little familiar. Yeah, no. Okay. Good. So g of 5. All right, so let's look at our g function. And what we're remembering here is this is an output of g of x. And what our answer is going to be is the input that gives an output of 5. Okay, so let's take a look at our g function. It doesn't look like we're given an output of 5 at all. So that means that g minus 1 of f of negative 1 does not exist. Okay. All right, so let's take a look at some inverses here. All right. Let's just have a look. How much of this can I do directly on here? All right, yeah, let's do an inverse directly on here. I'm going to zoom back in now because we're not going to have to look at 3 different sheets at once. And I'll just focus that sucker. Okay. So for each function, determine an equation for its inverse. Okay. So, to remind us how inverses work, the first thing we want to do is we're going to replace y and x. So switch them, actually. And so we're going to rewrite this expression with y here first. So it's going to be y is equal to root 2x plus 3 minus 4. And then we're going to replace x and y. So we're going to switch x and y. So that means we're going to have an x is equal to root 2y plus 3. And the negative 4 is outside the radical, like that. So that's a little scribble. Ignore. Okay. Then we want to solve for y. That's going to be our new function. So we're going to start by adding 4 to both sides. And so it's going to give us x plus 4 is equal to root 2y plus 3. And then we're going to square both sides. And I'm not actually going to expand that. I'm going to leave it in brackets. Oh, yeah, let's do that. Let's leave it in brackets. All right, so that's going to be x plus 4 squared is equal to 2y plus 3. Then I'll take away 3 from both sides. And I want to leave a bit of space here for this question because I know these questions can be tricky, quite tricky. So next thing we're going to do is we're just going to rewrite that as x plus 4 squared, take away 3. It's all equal to 2y. Oops. And lastly, we're going to divide by 2. And I'm going to divide each of these terms by 2. So we'll cross that out, and so that's going to give us y. I'm actually going to write the y on the left-hand side this time. It's equal to 1/2 of x plus 4 squared minus 3.5. Now, technically speaking, if you kept it in this form, it is true. Like I didn't ask you to simplify, so this is fine in this case. And the last thing we want to do is replace this y with f of x. We're going to turn y into f negative 1 of x, because this is the inverse function. It does the opposite of our original function. Okay, and that is our answer. All right, so we're going to try and repeat those steps for question 2 here, or 2b. So we're going to start by saying, okay, g of x, we'll let that be y is x minus 1 over 2x plus 3. Then we're going to switch x and y. So we're going to get an x is equal to y minus 1 over 2y plus 3. Now, This is where things can get a little funky. You know what? I want to make sure we got enough space here, so I'm just going to draw a little line here to make sure we don't get confused. There we go. All right. Now, the trick here is when you have a variable in the denominator, in general, you want to multiply both sides by the denominator. So we're going to multiply both sides by 2y plus 3. Both sides. 2y plus 3. Okay. That's going to cancel these guys out. And we'll distribute this x while we're at it. I hope that's not too quick for you guys. And we'll just write here on the left, that's going to give us 2xy plus 3x. That's going to be equal to y minus 1. Okay. Now we've got a couple of different y's here. So we want the y's all on the left, because that's what we're trying to isolate. And the x is all over on the right, or rather terms without y, because this guy doesn't have an x. All right. So maybe I'll just do one step at a time there. Minus y, and no, I'll also move the 3x over to the left. So minus 3x. So that should cancel these guys out, and it should cancel these guys out. We should get a new equation now. On the left, we've got, these are not like terms, so we can't add them together. So this gives us 2xy minus y. And on the left-hand side, that's negative 1 minus 3x. Okay. Now here is the hard step. Here's the trick. We can't group these together, so what we're going to do instead is we're going to factor a y out. So we're going to rewrite it as y and 2x minus 1 inside the bracket. That's equal to negative 1 minus 3x. And then lastly, we're going to isolate y. So we're going to divide both sides by 2x plus 1, or minus 1. 2x minus 1 divided by 2x minus 1. These guys cancel, and we're going to get y is equal to negative 1 minus 3x over 2x minus 1. And that's fine. However, if I wanted to simplify that, I can see 3 out of 4 of my terms are negative. And there just happens to be a habit, mathematicians, to want to try to write expressions with as few negatives as possible. So another way to think about that is multiplying the top and the bottom by negative 1, turning each of the signs in the opposite direction. So I'm going to multiply that and get 1 plus 3x on the top. And this will become negative 2x and plus 1, or 1 minus 2x. And lastly, I should rewrite that as the inverse of g is 1 plus 3x over 1 minus 2x. Okay. So next, we're going to draw an inverse. So I want to remind you that an inverse is a reflection over the line y equals x. So y equals x is a line with a slope of 1 over 1 and a y-intercept of 0. And it looks something like that. And so I'm going to just sketch that in right now. I'm going to put it in as a sort of dashed line so we don't confuse it with our graph itself. It's a reference point that helps us to envision whether we've drawn a correct inverse or not, because an inverse is a reflection over this graph. So, rather this line. So what we're going to do is we're going to, well, I think what I'll do is I'll just first figure out what is this. This is negative 6, 0. And that's negative 2, 0. That's negative, or 1, pardon me. Negative 1. That's 2, 2. And that's 3, 7, it looks like. And so what we do to draw an inverse is we're going to take each of these values, or inverses are all about switching x and y, just like we did in the last example. And so now we're going to physically do that. So on the new graph, we're going to have the point 0, negative 6. That's down here, so 0, negative 6. And it doesn't really pop that this is different than black in the video, I guess, so I'm going to try red. Hopefully that will be a little bit more obvious. And this one's going to turn into, I guess, 0 in x, or rather, that is not right. That's 0, -2. So now we're going to go 0 in y and -2 in x. So that gives us the point 0, -2. That looks a little bit more obvious that it's different. All right, 1, -1 is going to become -1, 1. That's -1, 1. 2, 2 actually reverses and becomes 2, 2. So actually that becomes our same point we had originally. And so that's true about any point that's on the line y equals x. So 2 for x, 2 for y, or 4 for x, or 4 for y, or so on. And lastly, instead of the point 3, 7, we're going to have the point 7 for x and 3 for y. That's the point 7, 3. And so lastly, we're going to try and connect these dots. So we're going to cross at this point here. And it's going to have kind of a funny little shape here. And, oh, that should have been up here. I was wondering why that was looking funky. At the point 7, 3, so I think I'll just try and find some white out here to white that out so that when we scan that answer key, it's not going to be confusing for people. All right. I always forget I'm supposed to shake this stuff. Guess I don't make enough mistakes. That's not true. Not true at all. Alright, so hopefully that dries and doesn't become too much of a smudge. Alright. So let's move on to question number 4. Gross. Alright, so I'm going to leave that to dry. So in that case, I'm going to stop this video, and we'll start it again on question 4.